Incredible news has recently spread across the internet. NASA has discovered evidence of a parallel universe. But is this actually the truth? Well, there is a grain of truth in this story, but it's not that simple. Let's consider it. Perhaps you've seen the articles that said NASA has finally found a parallel universe. This story was widely publicized, and people got divided into two camps: those who took this news at face value and those who considered it all complete nonsense. But both sides aren't exactly right. Let's start from the beginning. You'll stop one of them. Therefore, in order to detect them, scientists had to come up with some clever tricks. We know that neutrinos, like other similar particles, come to us from outer space. Ooh. They travel to Earth from the Sun, stars, and even from the Big Bang itself. Some of them come to us from particularly big sources, such as black holes, supernova, pulsars, and even from various unidentified objects. Some of these particles have particularly high energy, and for scientists, these neutrinos are the most interesting ones. But, oddly enough, most high-energy neutrinos don't actually come to us from afar. They form right here, next to Earth. This process has a cute name: particle shower. Well, this is how you can explain it in simple words. A granny particle gets into Earth's atmosphere. Usually it's a particle with very high energy. Then it generates several children that have less energy. Each of them then makes more grandchildren whose energy is even less than theirs, and so on, until we have a giant family tree of low-energy particles. In the end, there may be billions of them. During this process, piles of neutrinos are created. Then they begin to sink deep into our Earth. During their journey through the planet, they touch the upper layers of its crust or ice, for example, Antarctica's ice. When faced with all these obstacles, they create radio pulses, and as you might have guessed, these are the exact radio pulses that scientists are trying to find. It may be a surprise to you, but Antarctica is pretty deserted, you think? And that's why it's the best place to study microscopic particles, which usually can barely be traced. There won't be any interference or anything like that. We can catch these pulses with the help of powerful antennas. NASA places these antennas on balloons that can rise as much as 20 miles above Earth's surface. That's how they've been tracking these neutrinos for the past years. Alright, now we know what Anita is doing. But what about that parallel universe stuff? Nah, don't worry, we're getting there. In 2018, Anita began receiving abnormal radio signals that caused quite a stir in the scientific community. Remember how neutrinos come to us from outer space and then gradually sink deep into our planet? So, recently, Anita has discovered neutrinos that didn't descend from space as usual, but rather rose up from Earth. In other words, these particles, called tau neutrinos, basically travel back in time. But how is this possible? Scientists began to research them. At first, they thought that maybe it was a detector error or an error in interpreting the data. But no, everything was correct. Something very exotic was happening. If so, then first we must try to find a simple explanation. What if these tau neutrinos just came to Antarctica from some other source? Maybe they came to Earth from the other side and somehow passed through the boundary. To test this theory, scientists decided to seek help from another cool neutrino observatory called IceCube. Yes, very cool. This observatory is located near the South Pole. It consists of 5,160 optical detectors buried in ice. And all these powerful detectors are designed to detect neutrinos. Anita researchers were like, "Hey guys, we found some strange radio signals. Could you please check where they come from?" "No problem," Ice Cube replied, and started the research. And as a result, they found nothing. Yep, Ice Cube didn't detect any signal sources at all. It turned out that these strange particles had basically appeared out of nowhere. How could this be? Scientists tested many different theories, but none of them could explain the situation accurately. Later, Ice Cube published an article which basically said, "Nope, we have no idea where these signals came from and how to explain them in terms of the standard model of the universe." Oh, now it's getting interesting. So, what on earth are these signals? Having exhausted normal explanations, scientists began to consider ideas that go beyond our understanding. One of them said that perhaps these particles had come to us from a parallel universe where time flows in the opposite direction. This crazy-sounding theory is the result of the famous multiverse theory. According to it, about 14 billion years ago, when the Big Bang happened, two twin universes were born. One of them was ours, and the other was a parallel one. And they're almost identical in everything, except for some things. For example, time in this parallel universe doesn't move in the same way as it does in ours. It moves backward. Besides, everything there would look upside down to us, as if we're looking in a mirror. Therefore, scientists call it the antiverse, and believe it could be filled with antimatter. And even though all this may seem strange and crazy to us, for those who live in that antiverse, their way of life would be quite normal. In fact, they would rather find us, the strange ones. So these mysterious neutrinos could be born in this antiverse. Let's say they somehow existed there and then accidentally got into our world, where we were able to detect them. The idea of the multiverse itself is really incredible. If it's true, then it may mean that there is an infinite number of realities, many of which are much better than ours. Quantum mechanics even says that it's quite possible that every second of every day, any of your decisions divides the universe into two. And so there are quintillions of parallel universes where our lives have gone very differently. Something like this is hard to even imagine. Of course, it would be great if we could find a way to get into another universe, and if these mysterious tau neutrino particles were able to cross the boundaries of two worlds, well, maybe we can do that too? But unfortunately, this phenomenon alone isn't enough to say whether the multiverse theory is true or not. This is just one of several possible options. At this stage of human development, we cannot prove or disprove this theory. Maybe someday in the future, we'll find out the truth, but definitely not now. The only thing we can say now, after this discovery, is that we've found strange radio signals which standard physics can't explain. So we need to move in this direction and study them to learn more about this incredible phenomenon. But people like to dream about space, so no wonder we've gotten so excited about this. And it would be great if one day it turned out that this theory was actually true. The theory of parallel universes has been popular in various movies and books for a very long time. Where would you go if you found out that you could travel between realities? Me? I look for a different reality of ice cream.
Would you like to meet yourself from a parallel universe? Watch this video before answering this question. You have no idea what can happen. Let's look at this event from 3 different perspectives, where you meet 3 types of your double. The first type is the most realistic, but in some way disturbing. The second one can bring about the end of the world. The third type of your double can evoke a sense of existential horror. So let's start with the first type, and there's nothing out of the ordinary here. According to statistics, among the 8 billion people on the planet, about 80,000 are similar to you. There's a high probability that several people in this group look like your doppelgangers. You can even use special apps and websites to find them. Thanks to genes, more than half of the world's population has brown eyes. People may also have similar genes responsible for the shape of the face, nose, mouth, and ears. So there's nothing surprising about your double. but they're not completely identical to you. People who know you well will quickly distinguish you from your doppelgangers. Of course, there are people in the world with striking similarities. They can live on different sides of the planet and speak different languages, but their faces are almost identical. If you meet someone like that, you can have fun and prank your friends. But what if such a double wants to have your life? There are many movies on this topic. What if some guy or girl replaces you or wants to frame you? So be careful when you meet a doppelganger. Don't trust them until you're sure they're a good person. Okay, the second type of double is more complicated. To understand who they are, let's first understand the quantum world. First, you need to know that the quantum world is impossible to understand. Accept it and still try to figure this out. A quantum is the smallest particle of anything, a parameter that cannot be divided. All things are made of molecules, and all molecules are made of atoms, neutrons, and electrons. Light consists of photons. So electrons, neutrons, protons, and photons are all quanta because nothing can be smaller than them. The strange thing about these quanta is their unusual behavior. They can be in different places and nowhere at the same time. Our universe, like these quanta, can possibly exist in various forms. Yes, it sounds too difficult. In general, the main idea of this quantum world is that the laws of physics work differently there. For example, two entangled photons have a strong connection with each other. You stimulate one photon with a small energy charge, and it rotates. Another photon entangled with it will also rotate, but in the opposite direction. If you put these photons in different rooms, they will also react to each other. But the strangest thing is that when you put one photon on your desk and another one on the opposite end of the universe, they still remain connected. As soon as the photon on the table spins, the photon in the depths of space will do the same thing at that exact moment. The reaction rate between photons is much faster than the speed of light, and nothing in the universe can be faster than the speed of light, right? So how do they work? It seems like photons don't know what space is. This phenomenon is called quantum entanglement, and that's just one of the many incredible things. The rules of the quantum world constantly violate the fundamental laws of physics. Scientists observing quantum particles noticed that there was some other energy in this world invisible to us. We call it dark matter. It may be the reason for the strange behavior of quantum particles. Some experts believe that parallel universes are hidden inside this dark matter. So if you see your double from one of these parallel universes, the consequences can be unpredictable. They may come from a universe identical to ours or something completely different. Perhaps in one of the parallel worlds, the DNA of the first bacteria on the planet could have been arranged in such a way that giant cockroaches or octopuses were born instead of humans. In any case, meeting such a double might surprise both of you. And all this would mean that a rift has occurred between the universes, and one world can connect with another. What if these worlds start overlapping, leading to a collapse of universes? You might feel lucky to meet your double, but imposing one universe on another could result in the fusion of your bodies. Your double will merge with your body and you'll have 4 legs and arms, as well as 2 heads. You would unite at the molecular level into one humanoid mass. The scale of the disaster could become unpredictable. Just imagine these 2 worlds overlapping. Double roofs on houses, cars with 8 wheels, 2-headed dogs, and millions of other molecular anomalies. There's only room for one universe in one universe. The appearance of the third type of double will mean not the end of the world, but the end of your conventional idea about our universe. So think again about how entangled photons work. If one particle is on Earth and the other is at the end of the galaxy, they're connected, and their reaction speed is instantaneous. It seems like there's no concept of space for them, and it's inexplicable to us. Do you know in which world particles can behave like these photons? A virtual one. If you take 100 gigabytes of a video game and start to disassemble it, then, sooner or later, you'll reach the tiniest particle of information that cannot be divided. A byte. Now imagine a giant map of this game. The law of speed set for the players of this world remains unchanged. A character or item can't move faster than the developer allows. But there are no rules for bytes, kilobytes, and other bits of information because all this giant cosmic virtual reality works inside a tiny computer processor. You may have already guessed what kind of double we're discussing now. The development of artificial intelligence and virtual reality is happening at such a speed that in the next 50 years, we may be able to create a virtual world populated by creatures with intelligence like ordinary people. We will set the parameters of this intelligence so that all the game characters will think they live in the real world. You will create a hero who will be outwardly the same as you. People inhabiting this universe will build civilizations, develop their technologies, and create their own video games. And then, one day, you'll decide to contact your double and tell them their world is a virtual simulation. You'll tell them that inside this game world, bytes can interact with one another at any virtual distance. But from our perspective, as the creators of this world, bytes work inside a small gaming processor. It's like our quantum entanglement. Photons inside our giant universe are just inside another more advanced processor. And now imagine that you meet a double of the third kind, and they tell you that our world, planet Earth, and the entire boundless universe are all a simulation within another world, and that world is very different from ours. The difference between the two universes is the same as between megabytes and molecules. These concepts exist on entirely different planes. With this version of events, our laws of physics are just lines in the program code invented by a talented programmer. This knowledge will lead to existential shock, but some people won't care. And the most remarkable thing is that according to this logic, the other world above us can also be a simulation of another world, and your doubles will also exist there. In this sense, the universe will not be parallel. They will be very different from each other. The higher the level, the more complex the world is. But the question is, would you like to know this or continue to live your life? There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions. And one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And, according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept. There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And, of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would never have found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning and there was no end. It sounded pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But, unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry. They had the proof rubbed in their faces real soon. In 1965, astronomers Arno Pienzas and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Pienzas and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to -455 degrees Fahrenheit with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point. This cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist, though. This isn't just some mathematical error, it's right there. So what is this cold spot, and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one, perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision. For quantum mechanics, such crazy theories are pretty common, but for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analysis. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory. It could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it. How was our universe born? And if this seems hard to answer, then how about this? What was before our universe? While scientists are looking for the answer to the most difficult question in history, let's find out what they've come up with so far. In the 20th century, we've shed the light on this mystery, all thanks to this man, Edwin Hubble. One day on Mount Wilson in Southern California, he aimed his telescope at the sky and found out that these random clouds of gas flying everywhere are actually other galaxies, and there are a lot of them. And also, he learned something else, something that changed the world forever. They're moving. So what, you may ask? Well, it meant one very important thing. The universe is expanding. And if it's expanding, then it probably had a beginning somewhere, right? Now, all we have to do is run time backwards and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory. And here it is. Nothing has ever been anywhere because neither when nor where existed. Do you get it? But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects into the world, stars. And all this happened just some 12 to 14 billion years ago. Alright, now we know how our universe was created, but what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. Let's hang a balloon filled with paint to the ceiling and lay a white canvas on the floor. If we drop the balloon down, it will burst and we'll see absolute chaos on the canvas. A bunch of spots scattered everywhere randomly. Neither is like the other. But that's not really what the universe looked like. Instead of throwing a colored ball from the ceiling, let's draw a small red dot on the canvas. Now, let's expand it a little more, and capture this all on frame-by-frame shooting. We'll see a circle gradually growing in all directions. That's the reality. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration. something that was able to distribute everything in space instantly and evenly. Guth's theory was a success, and now most scientists rely on it. For most of them, this idea of the birth of the universe is quite enough. For most, but not for all. Martin Bojewald is a German professor of physics, and, in his opinion, the universe was born quite differently. Remember when we talked about cosmic singularity? The state of the universe in which it was small, infinitely dense, and super hot. According to Martin's theory, the singularity couldn't just appear out of nowhere. This is nonsense. But then, where did it come from? Let's look at a pendulum on an old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time, quantum time doesn't work that way. It's more like the second hand of a clock. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. See what I'm getting at? Let's go back to balloons again. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then guess what? The Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Bojewald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. Unfortunately, we don't have enough knowledge to find all the evidence for it, so for now, all this is just a hypothesis. But some people come up with even stranger ideas. Scientists promote such unusual theories that no one could even think of. Neil Turok, a South African physicist, and his colleague, Paul Steinhardt, an American theoretical physicist, look for answers far beyond our universe. They say that yes, our universe isn't the first one. There have been and will be an infinite number of them. And not only will there be endless Big Bangs, our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. This sounds incredible and frightening at the same time. But how does it work? According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on. Like pieces of fabric on a rope, these parallel universes are located near each other. Each one has a neighbor. We're not the exception. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until one day they finally collide. Their collision creates two Big Bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. But when they disappear, the brains collide again. And this will lead to the birth of a new universe. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Of course, everything described here is a great simplification. When you hear that our world is some piece of fabric on a rope, it sounds like complete nonsense. But this idea is based on string theory and M theory, two giants of quantum mechanics. If they turn out to be true, they could explain almost everything in our universe. Creating a theory is an incredibly huge process. Turok and Steinhardt made a huge amount of calculations and swept away many non-working theories. Also, to work this out, they have to overcome the limits of the human mind and think in 11 dimensions at once. Unfortunately, this crazy and elegant idea was laughed at. Turok and Steinhardt say that scientists are regular people, just like everyone else. They're also afraid of change and the unknown. And it's really scary to question everything we once believed in. Many years ago, people didn't believe that the Earth was round. Then, they were outraged by the Big Bang Theory. We can't make discoveries without struggle and fear. That's why Turok and Steinhardt don't plan to give up so easily. After all, the evidence that we have now only says that each of the 3 theories is equally possible. So which answer is correct? We may never know, at least not at this stage of human development. Unfortunately, as long as we have no evidence, we can only theorize. But maybe one day we'll find something that will open our eyes once and for all. Maybe one day we'll solve the mystery of how our universe came to be.